Why does software quality assurance matter so much in the nuclear industry? Picture this, a tiny bug in the software that controls a nuclear facility or a nuclear power plant's reactor. An overlooked software glitch could lead to a chain of events culminating in a catastrophic failure. This is why the nuclear industry relies on stringent quality assurance protocols like the ANSI-NQA-1 process to ensure that every piece of software works as intended every time. Imagine the software lifecycle as a journey. It starts with requirements identification. The what? This is the stage where the needs and expectations are laid out in detail. Think of it as the roadmap for the entire journey. The requirements need to be complete, accurate, and traceable to higher-level requirements, ensuring no detail is left unattended. Next comes the design phase. The how? It's like blueprinting a building, where safety, reliability, and regulatory requirements are taken into consideration. This comprehensive design forms the foundation upon which the software will be built. Then comes the implementation phase, which involves developing software code according to the approved design. It's akin to laying bricks and pouring concrete, following the blueprint to the letter. The focus here is on consistency, quality, and defect identification. Verification and validation follow, serving as the rigorous quality checks to ensure that the software meets specified requirements and functions as expected. This stage acts as a safety net, catching any issues that might have slipped through the cracks. Configuration management is the next step, acting as a control system for changes to the software throughout its lifecycle. It's like a meticulous librarian, keeping track of every version and change made to the software, ensuring everything aligns with the ANSI-NQA-1 standards. Testing is a crucial stage. It involves unit testing, integration testing, system and software testing, and acceptance testing. Think of it as a rigorous exam, ensuring the software meets safety and reliability standards as specified by ANSI-NQA-1. Documentation, akin to a detailed travel log, accompanies every step of the journey. This comprehensive documentation ensures that the software lifecycle complies with ANSI-NQA-1 standards from requirements to deployment, is accurate and facilitates understanding. Software Quality Assurance Plan is the watchful guardian, monitoring and auditing software development activities, ensuring compliance with ANSI-NQA-1 standards, and tackling any non-compliance issues. Training is essential for the journey to be successful. It ensures that everyone involved in the software development and maintenance processes is well versed in ANSI-NQA-1 standards and guidelines. Finally, the software is ready for deployment and maintenance. This is where the software is put into operation, and a maintenance phase with software change control in order to address any issues discovered post-deployment. And when the software has served its purpose, it enters the retirement phase, marking the end of its journey. In conclusion, the ANSI-NQA-1 process is like a seasoned guide, ushering the software through its lifecycle, ensuring strict adherence to quality standards, regulatory compliance, and comprehensive testing. This ensures the safety and reliability of software within the nuclear industry, making sure that every line of code, every algorithm, and every function works exactly as it should. Because in the nuclear industry, there is no room for error.